Exponents are the smaller number that is raised from the base. It tells us how many of the base numbers we have. So I would read this as 4 squared. What that means is I have 2 4s. So 4 squared looks like 4 times 4. And 4 times 4 is 16. If I have 4 to the 5th power, that means I have 5 4s. So it's 4 times 4 times 4 times 4 times 4. Well, 4 times 4 is 16, so this means 16 times 16 times 4. So 16 times 16 is 36, 9061. 6, 5, carry the 1, 2. So this all becomes 256, still times by 4, 24, 22, and 10. So 4 to the 5th, or 4 times 4 times 4 times 4 times 4, is 1024. We can't deal with negative exponents, so what we do instead is, if we have 4 to the negative 2nd, well, 4 is really a whole number, it's over 1. To work with 4 to the negative 2nd, then, we have to take it and push it to the other side of the division line. So this becomes 1 over 4 squared. The negative 2 became just a normal squared when we moved 4 to the negative 2nd to the bottom, becoming 4 to the positive 2. So now we have 1 over 4 squared is 4 times 4, and that means it's 1 over 16, 1/16. Likewise, 4 to the negative 5th can become 1 over 4 to the 5th, and that is also known as 1 over 4 5 times. 4 times 4 times 4 times 4 times 4. So that is the same as saying it's 1 over 1024. If we have the same base and we're multiplying, 2 squared means 2 times 2. And we're multiplying it by 2 to the 4th, 2 times 2 times 2 times 2. Well, how many 2's do we really have? 1, 2, 3, 4, 5, 6. So we have 6 2's, and so we could express that as 2 to the 6th, because the exponent tells us how many of the base, how many of these 2's do we have. So what this is doing is really saying the base, because they're the same, we're using that, 2, and then we're able to add the exponents, 2 plus 4. We add 2 2's, we have 4 more 2's, and that's how we get 6 2's in total. If we have 2 to the 5th, that means we have 5 2's. 2 times 2 times 2 times 2 times 2. It's being divided by 2 to the 3rd. 2 times 2 times 2. We have 3 2's on the bottom and 5 2's on top. But if we have a number divided by itself, it's going to go away. So 2 divided by 2 is 1. 2 divided by 2 is a 1. 2 divided by 2 is a 1. I have nothing left on the bottom except for 1's. So this really becomes 1 times 1 times 1 times 2, which means 4 on top. 1 times 1 times 1 on the bottom is just 1. 4 over 1 is known as 4. And that is because we have 2 squared on top. And so the 2 2's, being 2 squared, end up being 4. A different way of showing that, using the exponent rule, like noted above in the previous problem, is, well, if we're to move a negative, if we had 2 to the negative 3rd, we would get rid of that negative by saying it's 1 over 2 to the 3rd. So if we're over here and we have 2 to the positive third, if we move it up, it's going to become a negative. So that means 2 to the 5th times 2 to the negative third. Once we have it looking like this, it's just going to be what we did up here. You have the same bases, we have the same bases, so then we can add the exponents. So it becomes 2 to the 5 and negative 3. Well, 5 take away 3 is 2, so it's 2 to the 2nd, and that means 2 times 2, which means 4. So we see 2 to the 2nd shows up in both methods, and so then we get our final answers also being the same. 4 cubed squared. So this is raising a power to a power. This says to us 4 3 times 4 times 4. That's 4 cubed. But now we have it 2 times. So times, we have it 4 times 4 times 4. We have 4 cubed 2 times. So how many 4s do we really have in total? 1, 2, 3, 4, 5, 6. 4 to the 6th. The way we do that is 4 cubed squared. When you're raising a power to a power, you're going to multiply. So we could say 4 cubed times 2. 3 times 2 is 6, so it's 4 to the 6th, which shows the exact same thing as when we worked it out, longer way. So there are multiple properties of integer exponents. The zero exponent property says any value raised to a 0 is 1. So if I have 2 to the 0, it becomes 1. If I have 42 to the 0, it also becomes 1. If I have 7 million raised to the 0, it also is 1. Negative exponent property, that is if we have a non-zero number raised to a negative exponent, you move it across the division line, and then it becomes a positive. So if I have, let's say a is 2, and I raise it to the negative third, that is the same thing as saying 1 over 2 to the 3, 2 to the third. And so then we could say, okay, that is really 1 over 2 times 2 times 2. 2 times 2 is 4, times 2 more is 8, so that becomes 1 over 8. 2 to the negative third is the same thing as 1 over 8, 1/8. The product of powers property is when you have a number to some power times the same number to a different power, that's when you're able to add. So if I say 2 to the 7th times 2 to the 3rd, I could simplify that by saying it is 2 to the 7 plus 3, which means it's really 2 to the 10th. And that's because we have 2 7 times, so it's 1, 2, 3, 4, 5, 6, 7. Those 2's are being multiplied by 3 more 2's. 2 times 2 times 2. So then, instead of writing out all of that, you just count it up. We have 2 how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 10 times. The quotient of powers property, that is when we have a given number to a power divided by the same number to a different power. That's when we say a to the m minus n. And so that's what I was saying is if you move it up, the negative sign, the negative exponent, shows up when you swap its place. So then it would be times a to the negative n, but no need to have the double base, and that's when you can condense it to just be a to the m minus n. So if we have 3 to the 5th over 3 squared, well, I have 5 3's on top, remember, 3, 2, 3, 4, and 5, over 2 3's on the bottom, 1 and 2. Cancel out what you have on same top and bottom. I'm left with 3 3's on top and just a 1 on bottom, so that's 3 cubed. If I were to follow the quotient to powers property and say, okay, 3 to the 5th, and I bring it up, the bottom, 3 to the negative 2, I can condense that to be 5 and a negative 2. 3 to the 5 minus 2, which is the same as saying 3 cubed. That gives me the 3 3's left on top, and so 3 cubed is good, or I could say that's also equal to 27. The power of a product property, saying if I have, let's say, 2 times 3 squared, that's saying I have 2 times 3, 2 times 3. What the power of a product property says is you could distribute the exponent, the 2, to everything inside. So it's 2 squared times 3 squared. I have 2 3's and 2 2's, which if we look at this, well, 2 times 2 from both parts, and 3 times 3 of these two as well. 2 2's, that's what I have here, and 2 3's, which is what I have there. Finally, we have power of a power property. A to the m to the n. Power to a power. So if I have 2 squared to the 3rd, the power of a power says that I can multiply the exponent. So I could say 2 squared times 3. 2 times 3 is 6. So it would be 2 to the 6. And that is because we're saying I have 3 2 squareds. So I have 2 squared 3 times 2 squared times 2 squared. And yet 2 squared means I have 2 times. 2 times 2, 2 times 2, 2 times 2. How many 2's do I have in total? 1, 2, 3, 4, 5, 6. I have 6 2's. So you can see on this picture, we have other examples similar to what I worked out using some different numbers that you could copy down in your notes if you would like to have more references to use.